Ionic compounds are all over the place. They occur very frequently in the Earth's crust as minerals. Gemstones are ionic compounds. They're present in the foods that we eat. Salt is an ionic compound. Ionic compounds are very stable in general because those ionic bonds, the attraction between positive and negative charges, is very strong. So once they've stuck together that way, it takes a lot to get them apart. Some examples, Tums contain calcium carbonate. It's an ionic compound. Morton's light salt is a mixture of sodium chloride and potassium chloride. And here are some minerals. Calcite is also calcium carbonate. It's just a different form than what's in the Tums. You wouldn't want to chew on these rocks if you had heartburn. And this is trona. This is a crystalline form of this messy thing, but also an ionic compound. So how do we write the formulas for ionic compounds? Here's a list of instructions. I know some of you really like lists of instructions and others of you don't. So these are just here for you that like them. The first thing is we need to write the symbol for the metal cation with its charge, and then we need to write the symbol for the nonmetal ion with its charge. There should probably be the word anion in here. Then what we need to do is we need to put subscripts on the cations and the anions so that when we put those ions together, their charges will add up to 0. And then we need to double check that we did this okay and that everything's adding up. So those are the instructions. Those maybe didn't make a lot of sense. We'll do some examples here in a minute. So important to remember, ionic compounds always contain positive and negative ions. The first element is usually a metal. The one exception that we're going to see in this class is this cation, ammonium. It's not a metal, but it is a cation. So if you see something that starts with NH4, it's an ionic compound. The sum of the positive ions, some of the charges of the positive ions have to add up to equal the sum of the negative charges. And the formula is going to be the smallest whole number ratio of ions. So let's do some examples. Write the formula for the ionic compound that forms between potassium and sulfur. Well, what's the element symbol for potassium? K. And what kind of an ion, what charge will this have as an ion? +1. How do we know that? It's in group 1A. All the elements in group 1A form +1 ions. Okay, and sulfur is S, and what charge will that have as an ion? -2. It'll be -2, S2 minus. We find that from the periodic table by starting at the right side, argon, and counting left, negative, -1 to chlorine, -2 to sulfur. So it's just from its position in the periodic table. Now we have to figure out how many of these and how many of these do we need so that when we put them all together, the charges add up to 0. So one way to do this is, okay, well, let's just look and see what's our total here. Well, with one positive potassium ion, I've got a +1 charge, and over here, I've got a -2. Okay, I want these to be equal but opposite in sign. So I want this to be -1 or this to be +2, so they'll add up. I can't change the charge on this, and I can't cut the ion in half. I can only add more ions. Well, if I add another potassium ion, so I have 2 potassium ions, then the total positive is +2. If I put 2 of these ions and 1 of those together, the charges would add up to 0. So the formula will be K2S. 2 potassium ions, 1 sulfur ion. We don't show the charges in the formula. It would be very messy. We've already got enough trouble with the subscripts. If we throw in all those superscripts, it's going to just be very, very ugly, so we don't do that. There's another way to do this. So that's one way. Actually, there's two other ways. One of the ways, and this is for you who have math brains. I know I have some of you in here. You look at this +1 and this -2, and you're looking for the least common multiple. The least common multiple is going to be 2. So you multiply this by 2 to get 2, and you multiply that by 1 to get 2, and then you've got it. I'm not going to go over that because people who get that, and they don't need any extra explanation. And me explaining that to those of you that don't get it isn't going to help anyway. That's why I'm giving you this other method. So this is more of a visual method, a true understanding of what's going on kind of method. And then there's the shortcut method that works most of the time that we call crisscross. So the crisscross method says, write these two ion formulas with their